I feel like I haven't used. I don't know what I'm thinking. I feel like I haven't made a recording in a long time. It's been a while. But I'm feeling okay. Feeling okay. All right. So we're solving exponential equations, and it's pretty easy. This is really leading towards logarithms. And you'll see there'll be a specific case, or soon there'll be a specific case where like, how in the heck would we solve this? Anyways, I want to get a good 30 minutes in. Practice is the key. Some people haven't figured it out yet, but yeah, that's the key. All right, so let me zoom in just a little bit. I can't see. And let's sneak in 30 minutes. All right, so number one, we want to solve each equation. We got 3 to the 5x is equal to 27 to the 2x minus 4. All right, no big deal. We want to get the same bases, so we'll say 3 to the 5x is equal to 3 to the 3, which is 27, and get 2x minus 4. All right, so we get 3 to the 5x is equal to, when an exponent's raised by an exponent, you're going to multiply them, so we'll get 3 to the 6x minus 12. Sure. Should make sense if the bases are the same. The exponents must be the same as well if you have equality. So you have 5x is equal to 6x minus 12. And when you solve this, let's see, you'll get negative x is equal to negative 12, or x is equal to 12 as the answer. No big deal. On to 3. Come on, 30 minutes. It's been a while since we've had 30-minute homework. We got 2 to the 6x is equal to 32x minus 2. Same idea, so we'll get 2 to the 6x is equal to 2 to the 5th is 32. So we get x minus 2. I get 2 to the 6x is equal to, I will exponent raised by an exponent, I'll multiply, so I get 2 to the 5x minus 10. I got equality here. I got 6x is equal to 5x minus 10. I get x is equal to negative 10. Pretty easy. Pretty standard. Skipping 5, on to 7. Solving inequalities. That's not too bad. So we get 4 to the 2x plus 6 is less than or equal to 64 raised to the 2x minus 4. Okay, so, No, we're fine. So you can get this into like base 2, because 2 to the second is 4, and 64 is 2 to the 6. Or you can get it in base 4. You just got to recognize like what base to get them in. So I'm going to keep them in base 4. It's going to be easier. Numbers are going to be smaller. Is less than or equal to 4 to the 3rd times 2x minus 4. Again, when I'm an exponent's raised by exponent, I multiply. So I get 4 to the 2x plus 6 is less than or equal to 4 to the 6x minus 12. Exactly like that. I'll go ahead. Should make sense, like if the bases are the same, and we're saying this expression is less than that expression, then we can set the exponents in the same inequality. So you can say 2x plus 6. 2x plus 6 is less than or equal to 6x minus 12. And then we'll solve this equation. So I guess I'll move the x over here. So I get negative 4x is less than or equal to negative 18 or so. Sure, 18. Divide, so I'll set x is greater than or equal to 18 over 4. Or if I want 9 over 2. Or if I want 4.5. There we go. No big deal. I feel like I should check answers. I don't know why I haven't been. Careless. All right, 9. 9 says 8 to the 4x plus 2 is equal to 64. We're going to do the exact same thing. Get them into base 8. So we'll say 8 is 4x plus 2. And this is equal to 8 squared. Once the bases are the same, then we can set the exponents equal to each other. So we get 4x plus 2 equals 2. The 2's are going to cancel out, so you get 4x is equal to 0, x is equal to 0. Should we check? Yeah, it's easy check. You get 8 squared is 64. 11. I got 81. A plus 2 is equal to 3 times 3a plus 1. Get this in the base 3. It turns out that 3 to the 4th power is 81. That's not too hard because like 9 times 9 is 81 and 3 squared is 9. So you get 3 squared times 3 squared, which is 3 to the 4th. And this is raised to the a plus 2. And this is 3a plus 1. When an exponent's raised by an exponent, we're going to multiply. So we get 3 times 4a plus 8. And this is equal to 3 to the 3a plus 1. I'll set them equal to each other. I get 4a plus 8 equals 3a plus 1. I get a is equal to negative 7. If I did that right. Looks good, looks good. 11. Awesome. 13. Changes the color here. Wow, this is like, I don't know why this is hard for me today. I don't think I'm quite ready to do math. Let's see, 27, 3, c minus 1. Yeah, c minus 1. Okay. Not that you have to be careful, but the 9 to the nothing is going to give us 27. You have to, well, it'd be some rational exponent. You have to get these into base 3. So I'll say 3 squared raised to the 3c plus 1 is equal to 3 cubed raised to the 3c minus 1, which isn't bad. So this is 3 exponent raised by an exponent. We multiply, so we get 6c plus 2. And we get 3, and we get 9c minus 3. Once the bases are the same, you can align the exponents or equate the exponents. 6c plus 2 is equal to 9c minus 3. Looks like a fractional answer. So I get negative 3c is equal to negative 5. So I get c is equal to 5/3 as my answer. No big deal. On to 13. Wait, that was 13. Yeah, on to 15. No, thank you, word problem. On to 17. Yeah, we'll take a look at 17. I think. Let's see, 17. 30 minutes. It says, write an exponential function for the graph that passes through the given points. I'm assuming the horizontal asymptote is 0. So I'm guessing it's in like this format. F of x is equal to a times b to the x. And the k value is 0. I think so. Yeah. All right, so they gave us 2 points for 17. The 2 points were 0, 256. That seems convenient. And 4 and 81. These aren't that hard. All right, so when I plug 0 in for x, I'll get 256 is equal to a times b to the 0. But b to the 0 is just 1. That goes away. And a is equal to 256. So we have the equation f of x is equal to 256 times b to the x. We'll plug in the other point. So we get 81 is equal to 256. Yeah, that seems so weird. Just going to go with it. times b to the, help me out here, can't think, oh yeah, b to the fourth, we're plugging in that point. So we get 81 over 256 is equal to b to the fourth. All right, so we're going to take the fourth root here. Fourth root of 81 over 256 is equal to b. Let's simplify this. You should see before that 3 times 3, or 3 to the fourth power is 81. So we get like 3 to the fourth power. Now we've got 256. I believe that's 4 to the fourth power. I believe so. Yeah, because 16 times 16 is 256, I believe. Let's see, that's 36. That's 9. That's 16. Yeah, 256. All right, so we'll take the fourth root of that, which is b is equal to 3/4. So we'll have the equation f of x is equal to, let's see, 256 times 3/4 x. Give me 1 second. All right, I looked at 19. I just think the numbers are too big. Try to like do problems that don't require calculators. All right, so skipping 19. Pass on the word problems. Well, I think we're gonna have a word problem lesson tomorrow. Let's see, on to 25. Okay, here we go, 25. I feel like I'm stalling. 25, so I got 10 to the 5b plus 2 is greater than 1,000. All right, no big deal. I'll say this is 10, 5b plus 2 is greater than 10 to the third power. 1,000 is 10 to the third power. We're going to set up the inequality of 5b plus 2 is greater than 3. Looks good. So I get b is greater than 1/5 maybe. Perfect. Looks good to me. All right, on to 27. With plenty of time. 27. I get 1/27th. Interesting. Raised to the 2d minus 2 is less than or equal to 81. D plus 4. Okay, so this one is base 3. So 3 to the third power is 27. 3 to the negative third power is 1/27. So this would be 3 to the negative third power is 1/27. So we get 2d minus 2, which is less than or equal to 3 to the fourth times d plus 4. Or how about that? Perfect. When an exponent's raised by exponent, we're going to multiply. So we get negative 6d plus 6 is less than or equal to, I skipped a step there, just saying the exponents equal each other, 4d plus 16. And we have a little bit of an issue here. There's some negatives floating around, but we'll try to figure this out. I don't know. Negative 10d is less than or equal to 10. So I get d is greater than or equal to 1. Negative 1? Negative 1. Yeah. Looks good. Looks good. On to 29. We're 15 minutes in. I wanted to make 30 minutes, but I got tired. My stamina is not the greatest right now. Is less than 1/216. Is that 4w? Yep, 4w. Okay, so you gotta use a little logic here. So we gotta get on the same base. Obviously, 6 squared is 36. think we want to work with that. Now it's 1 over 36, so we need 6 to the negative 2. And this is going to be raised to the w plus 2, which is less than, all right, now 216. So I don't know if this is obvious, you know, it's like we have different backgrounds in mathematics, but I know it's going to be 6 to something. I just don't know which one it's going to be. 6 to the third power? Maybe. If we do 6 to the third power, all right, so we get 6 squared, which is 36, times 6. I get 36. I get 18 plus 3, which is 21. Look at that. So I'll say 6 to the negative third is the same thing as 1 over 216. And I'll raise this to the 4w. When exponents are raised by exponents, we multiply exponents. And I'm going to line the exponents equal to each other. Negative 2w minus 2 is less than negative 12w. I'll solve. I get 10w is less than 2. And I get w is equal to or less than 1/5. This was problem number. I don't know if I got this right. Give me 1 second. I see it. All right, so when this negative 2, this is actually going to be negative 4. And this will be 4. And this will actually be 2/5. Sorry about that. Yeah, I don't know if I'm like well enough to do math right now, but we'll give it a try. 31 is a skip. 33, same stuff, you know. So here's 33. I got 1/5 to the x minus 5 is equal to 25 raised to the 3x plus 2. Okay, same thing. Obviously base 5, so this is going to be 5 to the negative 1 is the same thing as 1/5. X minus 5 is equal to 5 squared raised to the 3x plus 2. So I get negative x plus 5 is equal to 6x plus 4. Solve. Sure. I'll move everything over here. 7x is equal to negative 1. X is equal to 1/7. That's our answer. It's not bad. On to 35. Is that a 1/8? Yep. 1/8 raised to the 3x plus 4 is equal to 1/4 raised to the negative 2x plus 4. Okay. Got to get to base 2. So we get 2 to the negative 3 raised to the 3x plus 4 and 2 to the negative 2. I hope that makes sense. Like 2 to the third is 8. So 2 to the negative third has to be 1/8. 2 to the second is 4. So 2 to the negative second is 1/4. Multiply. Negative 9x minus 12 is equal to 4x minus 8. Let me check my work here. Looks good. Solve, I guess. Negative 13x is equal to, doesn't feel right, but whatever. Positive 4. X is equal to negative 4 over 13. Whatever's. 37, oh my god. I don't even know. Okay, no, I know. Okay. Just looks painful. 37, 25 over 81 raised to the 2x plus 1 is equal to 729 over 125. And this is raised to the negative 3x plus 1. Okay, I mean, a little bit of logic here. But obviously, like this guy and this guy are both base 5. So just using some additional logic here, I'm going to say these are both base 9. Actually, that's pretty obvious to see. So this guy is going to be 5 squared over 9 squared, 2x plus 1. And this is going to be 9 cubed over 5 cubed to the negative 3x plus 1. So we have to invert one of them. So we either use the base 5 over 9 or the base 9 over 5, but I don't think it matters. I'm going to use 5 over 9. So this is 5 ninths squared, and this whole thing is raised to the 2x plus 1. Okay, now I have to invert this. We have to pick up a negative exponent. And this is obviously, 9/5 to the third power. So this is going to be 5 ninths to the negative third power. And this is raised to the negative 3x plus 1. All right, I'm going to go ahead and when an exponent's raised by an exponent, I multiply them. So I get 5 ninths raised to the 4x plus 2. And on this side, I get 5 ninths raised to the 9x minus 3. Once the bases are the same, we can line the exponents. So we get 4x plus 2 is equal to 9x minus 3. And then I solve away. It looks like we're going to get 1. Yeah, I think so. So I get negative 5x is equal to negative 5. And we get x is equal to 1 as our answer. 22 minutes in. Let's see what else we got. Let me check the hard problems. Give me 1 second. Ooh. I think I'm done. There's some good problems though. I like it. Thank you.